So yeah, I'm Joe. Is this too loud? Feels loud. OK, all right, good. All right, so I'm Joe. I'm an engineer on the React team at Meta. And in this talk, we'd like to share our vision for client-side React development. Specifically, I'm talking about React Forget. Forget is a compiler that we've built at Meta that automatically memoizes your components and hooks. So if you were hoping for us to be open sourcing Forget today, I am sorry to disappoint you, but we've made a lot of progress, and we're excited to share more about that with you today. So I'm going to be talking about what our vision is, what Forget is, and how it fits into that vision. And then Mofei is going to come up and talk about our progress shipping Forget at Meta. So to understand our vision for React, it helps to look at some code. Here, I'm showing a simplified version of an internal component from Meta. This component takes a heading, a list of videos, and a filter, and then it renders the heading and list of videos that match that filter. You can imagine the real component is more complicated. The filters actually state, et cetera. But it's kind of a simplified version. So personally, I think there's a lot to like about this code. It's a small, clear, concise component. It uses plain JavaScript values, arrays. We use standard JavaScript syntax, if-else for conditionals, a for loop for iteration. Right? We don't need to learn something new. This is just the JavaScript that we already know. Use the platform. So in a lot of ways, this is React at its best. UI as a simple function of data. There's really only one potential problem with this code. If we were to ship this as is, we might see that parts of our app re-render unnecessarily, and that can affect performance, slowing things down. So let's see an example of how that can happen. Imagine that our component re-renders, but only the heading has actually changed. When the component re-renders, it passes that new heading down to the heading component, which updates as we'd expect. But that's not all that happens by default. When our component re-renders, the entire component reruns. This entire function reruns. That means we create a new filtered videos list, and then we pass that to video list, which then also re-renders all the way down the tree. And this will happen all the way down the tree, even though nothing meaningfully changed about the videos. To address this, we can use two React APIs, useMemo and React.memo. So here, I've applied useMemo to the logic for filtering the videos. The array at the bottom here tells React to only recompute filtered videos if the videos or filter values have actually changed. So now, if only the heading changes, we don't recompute the list of filtered videos. Great, but that's not quite enough. Because even though we're passing the same filtered videos down to the video list component, by default, React will still re-render a component even if its props haven't changed. To opt out of that, we wrap the component with React.memo. So now we get the expected performance. With these two changes, now when heading changes, we won't have to update the video list component. Great. And if you judiciously apply React useMemo, use callback, which is for kind of the callback version of useMemo, and then React.memo. If you use them consistently throughout your code base, you can achieve really good performance with React. And a lot of other presenters have talked about that earlier. We found that generally when applications do have a performance problem, it's because of this kind of missing memoization. And it can be fixed by just adding this back. But this memoization has made our original code a lot less concise and clear. We're no longer simply describing what the UI should be showing. We're having to tell React how to process our code. That's kind of losing some of the original idea of React, right, declarative rendering. But now we're having to go into the how. And then our code reviews become about whether we've memoized correctly, whether we memoized too little, too much. We get blog posts arguing that you should memorize everything, blog posts saying that you shouldn't memorize at all, you don't need memoization. And the thing is that both of them are kind of right, because it all depends on the context. This code, the original code here, might be fine in a lot of apps, but for other apps, they might run into a performance problem. But really, with this memoization, our code gets cluttered up with extra logic. We're not just focusing on the core product experience, we're focused on, again, how to achieve it. It makes our code harder to read and harder to change. So in a sense, useMemo is a compromise. We sacrifice some of the clean, concise, original logic in exchange for better performance. But why do we need to make this compromise at all? Well, let's go back to the code. The reason we started down this whole path was that we needed to use useMemo to tell React that the video list doesn't depend upon heading. But we're all developers, we know JavaScript, right? We've already told React that video list doesn't depend upon the heading. In fact, we've used a very well-specified format of instructions that computers already understand to tell React that information. It's called JavaScript, you already know it, right? So why do we have to tell React again? Why do we have to also add in our use memo to tell React, oh, this doesn't depend upon these values? What if React could figure that out automatically? And better yet, what if React could figure this out at build time when you compile your app and you didn't need to pay a runtime cost? Rather than do some fancy dynamic tracking of values at runtime, we could just figure this out ahead of time and avoid the runtime overhead. So that's the goal of React Forget. It's the code name for this compiler that we built at Meta to automatically memoize React hooks and components. This lets developers write code without needing to manually memoize while achieving the same performance as a well-memoized app, and in some cases, even faster. So to make that really concrete, React Forget lets you write the original code I started with no memoization, while getting performance at least as good as the manually memoized version here. So Forget really helps in two ways. It simplifies the developer experience, because developers don't need to think about memoization. And it helps ensure that we're achieving optimal performance by default. So let's take a look. Let's see. Will the swiping actually work? All right. Hey, there it is. OK. Oh, wait, hang on. I forgot. I got to grab the code. Let's grab that code. Where was it? It's here somewhere. All right, I'm going to exit out. Let me grab the code. Got to make sure we get the right code. That looks like the right code. OK, let's grab that. Go over here. So what I'm showing you here is our internal compiler playground. I got some example code in there. I'll swap that out. For anyone who's really curious about Forget, you might want to look at that code, but we'll look at this code. Nope, I messed up. Live demos, gotta love it. All right, there we go. So this is our internal compiler playground. This is meant for us to use when we're developing the compiler. You don't need to understand, this is a tool for us, not for the typical React developer. I'm just showing it here just as a way to demonstrate the compiler. So again, I pasted in the original code we started with, right? And so this is the input, and then this JS panel over here is showing the output from the compiler. So let me zoom in a little bit to make sure y'all can read that. All right, that's probably good enough. All right, okay, let me scroll. Sorry, it's hard for me to see exactly what you can see. All right. Yeah, all right. Okay, cool. So now remember, there was no memoization here. But Forget has figured out that it should memoize filtered videos. This block is equivalent to a use memo. So I'll highlight all this section here is all about memoizing filtered videos. So what does it do? So first, it checks to see if videos or filter have changed. Forget figured out the dependencies automatically for this value. And then it takes the code that we wrote and just moves it inside. Right? It's not reformatting our code, it's keeping the same code that we wrote with a for loop and an if statement, and just moving it inside this memoization. We call it a memoization block. And we have source maps to preserve the source locations for this, so that all works. So then after computing the new value, Forget saves what the inputs were so we can compare them next time. And then it saves the output, right? It saves the filtered videos. So now imagine that we re-render and only the heading has changed. Well, we check, have videos and filter changed? No, they haven't. So we go to the else block and we grab the previously computed value. So the net result is just like use memo, right? It's the same exact behavior, just a slightly more efficient implementation. Instead of having to create a function expression, which allocates memory, not great, we can avoid that and just do a regular if statement. Instead of allocating an array for the dependencies and dynamically iterating them, we're using static JavaScript code, which can be optimized by the JavaScript engine. But forget is actually memoizing even more, right? This is more memoization than we thought to do. So you can see a bunch of stuff here. Let me scroll down and pick just one example. So here's the video list. So forget is actually memoizing the JSX element itself. As long as filter videos hasn't changed, we don't recreate the element. And what this allows React to do is basically the same thing as a React.memo. So as long as filtered videos doesn't change, we'll put this exact same JSX element into our output. And when React gets to it, it sees, oh, the JSX element at this spot was exactly the same. I can skip re-rendering. Obviously, if there's a state change, it has to re-render. But in general, just like React.memo. And so this is where forget can memoize even more than a developer would typically think to do so. OK, so let's go back over to the presentation. Pick up here, presenter view. Those are my notes. All right. All right, and I got to find my place. Where was I? OK. Yeah, OK, that's all the other stuff. All right, OK, so that's kind of looks pretty magical. Forget just figured out what to memoize. How does it actually work? So if you're not familiar with programming language theory or compiler design, this may feel pretty magical, but it's not magic, it's computer science. Forget is a low-level compiler for React. It's really specifically designed for React. And by low level, I'm referring to the fact that forget builds a detailed internal representation of your code. It understands the rules of JavaScript, and it understands the rules of React, and it can use those to figure out what parts of your application to memoize. And these optimizations are things that are typically done by traditional compilers for languages like C++ or Rust, in addition to some novel analysis that we came up with. So that kind of together with understanding the rules of JavaScript and React, we can kind of carve out a safe space for us to apply these optimizations. So by earlier this year, we'd established a solid foundation for the compiler, and we began a series of production experiments. We used forget on increasingly complex and high-traffic surfaces. To tell you more about that part of the story, I'll hand things over to Mofei Zhang. Nice job.
Hey, everyone. Wow. I'm Mofei Zhang. I'm an engineer on React, and I've been working on Forget since last June. It is so exciting to be here and finally be able to talk about this project. This year, we took the Forget compiler from an ambitious proof of concept to something that is now running on 2 major meta products. That's right, you can now find this project out in the wild. I mean, some folks in the audience may have already used Forget compiled apps. Our work is not quite done, but I'm so proud of how far we've come, and I'd really like to share with you our journey so far. So, about 8 months ago, we felt that Forget was finally complete enough to start shipping at Meta. We had painstakingly walked over every edge case we could find in JavaScript, and there's a lot of them. Our GitHub repo held over 500 tests, and each test checked that we were correctly analyzing and memoizing every permutation of valid React functions we could think of. We had really crafted this compiler with care, iterating on its design with a lot of code samples from complex meta products. And we were finally ready for our next step, understanding how this compiler performs on real apps written by real engineers and on real devices. Does Forget actually do what it set out to do? Make any React app it touches better? Introducing our first collaborator, Quest Store, the app store for Quest VR devices. Quest Store has a large code base written in React Native. Our primary goal was to free its developers from needing to worry about menu memoization. While we were hopeful, we thought our chances of actually improving performance were low. Quest Store engineers had already spent a lot of time profiling and hand optimizing this app with use memo and use callback. Needless to say, we also had to move with a lot of caution when integrating Forget here. During rollout, every single test would run twice, once using Forget compiled code, once without Forget in the pipeline at all. We also partnered with QA testers and even data scientists to check that we weren't changing product behavior. This is the product details page on Quest Store. It shows all the details of our product on the store. This page is pretty complex. As you can see, there's 5 or 6 sections that you can scroll or click through. Each section, like gallery or about, has its own complex UI logic. Forget has now been entirely rolled out on this page, meaning that every React component and hook is compiled by the Forget compiler. After enabling compilation, we thought that page interactions felt a bit more responsive. I was skeptical about this. That sounds almost too good to be true. So to understand if Forget actually helped, we used the React profiler to record the re-rendering work following a click on the left nav bar, like clicking from gallery to reviews. So this is the work done by one React render following the click before we turned on Forget. For anyone not already familiar with the React profiler, this entire diagram shows a React component tree with each individual box representing a React component. Green boxes show components that were invoked during this re-render. Gray boxes represent components that were not called. As you can see, many boxes are green here, which means that this particular re-render required a lot of work. But if you remember from earlier, a lot of engineers had already tried to optimize this app. So the gray boxes in those subtrees that you see is what the work that they were able to save React. Now, let's take a look at the Forget compiled version to see if anything changes. As a hint, keep your eyes on the components outlined in red. Okay, ready? So over half of those re-rendered components kind of disappeared. This means that re-rendering now requires much less work when using compiler-optimized React. Awesome, but what was the difference? We compared existing memoization in the code base with Forget's output, and it turns out compilers can do memoization pretty well, often even better than hand-optimized code. So let's take a look at some simplified code from this page to see how. So actually, I'm going to full-size that screen. I think it's flashing, and I'm going to click through a lot of slides. Hopefully that's better. So this is some logic from an extremely stripped-down version of the media preview component on this page. It looks like a lot of code still, so let's walk through it together. Media preview receives a media object, which it renders. If the media object represents a video, we return a video card. We also want videos to autoplay when users hover, so we pass a pointer event callback. And otherwise, if our received prop is not a video, we return an image card. For images, we always show a tooltip on hover. Now, media preview looks pretty small here, but on the real Quest store, this is a really complex component with a lot of props in state. It returns either video card or image card, both of which have many React children. In addition, this page displays many media previews at once in the form of thumbnails. This all means that changing state, like toggling the focus state of this page, could make all of these components re-render and make this page pretty laggy. So let's try to optimize media preview. So I'm sure a lot of people here are React experts, React Advanced and all, and they can immediately tell me, hey, you're creating a new function on every render. We need some use callbacks in there. All right, so let's do it. Create a use callback, which has to be outside the if branch because of rules of hooks and all. Move the video handling code to our callback. Move the image handling code to our callback. Oh, and we need a dependencies array, right? No problem. We see that media, app, and focus and show tooltips are all used. So let's add them. Take a step back, and that's pretty hard to read, isn't it? If we were to ask a new member of Quest Store to add a feature to media preview, like pausing the video when a user stops hovering, it would be entirely reasonable if they just added a new callback. It would also be entirely normal for me to stamp this change, ship it, right? But there's one problem. This change just broke our carefully memoized component. Re-rendering media preview will now again always cause all of its children to re-render. Oops. Mistakes like these show why it is so difficult to maintain the performance of a carefully optimized app. Just missing a single use callback may invalidate tens or hundreds of components, just like we saw in the profiler graph before. Reading through the hand optimization done by Quest Store engineers, we saw that many components had many use memo calls, but inevitably, some other props or components were added later without being memoized. Now let's undo all this memoization and look at how forget would transform this function. Forget has a bit of an unfair advantage when compared to humans. It's a program. I mean, specifically a compiler, but all compilers are programs. And programs are really good at being systematic. So forget sees that media previews accesses a couple of values to pass to its children. Media.url is directly accessed, but it doesn't need to be memoized. It's just a value off of a prop. Aha, but this code creates a function, and it depends on app in focus and media. No problem. As Joe showed previously, forget can memorize this function. This code also creates a function, so forget can also memorize that function. On Quest Store, forget systematically memoizes values, so humans don't need to worry about making mistakes like forgetting a use callback. They can just forget it. By the way, our compiler has some other cheat codes. If you squint, you notice that it can memorize within if branches and other conditionals. I would really like to talk more about this, but couldn't fit it into this slide. So let's take a look at some results from Quest Store. We saw major improvements in interaction responsiveness for Quest Store in production. Interestingly, we also measured loading metrics like visual completion to be faster. It turns out that the initial load of this page requires multiple re-renders to initialize things like video state. By memoizing according to its fine-grained understanding of reactivity, forget reduced the amount of work done during re-render. With forget, re-renders completed faster. So that means we got our answer, right? Forget is done and will automatically make our React apps better all the time? Not quite. Forget's success here helped us gain a lot of confidence in its memoization strategy. But we know that fast renders are just one piece of what makes a performant UI. Fine-grained memoization is great for interactivity, but if our compiler memoizes too much, it may adversely affect other app metrics. We had a lot of ideas for how we could improve the compiled output. But first, we needed more data. Instagram.com is a React app built for the web and presents a different set of challenges from Quest Store. On web, memoized code translates directly to an increase in bundle size, which may in turn increase startup time. We also wanted to know if caching values created during render negatively affects memory-constrained devices, like older Android models. And of course, we hoped that forget could make developers' lives easier. If you have visited Instagram.com in the past month, you might have used forget. That's right, forget is on Instagram pages like profile, in production, as you can see here. So we're already gaining an early understanding of how forget affects metrics other than rendering speed. On the profile page, we measured less than a 1% increase in compressed code size and similar changes in retained memory. In production, we have so far seen no increase in memory-related crashes or startup time. Instead, we again saw slight improvements in visual completion, just like our results from Quest Store. Oh, and there's something I forgot to mention about all of this. We used forget to achieve these results without needing to make any changes to product code. Forget can handle almost all JavaScript syntax we actually seen in use. It currently understands 95% of components on Instagram.com, and we're working to increase that even further. So what's left? The performance wins we have seen from Forget have exceeded our initial expectations. However, on the React team, we have a really high bar for releasing products. Forget is not an exception here. Our milestones are to first build a minimal proof of concept, then a version that has almost all the necessary features, carefully roll out to a small number of products, getting feedback and iterating on our design. We're at this stage now, by the way. We're working to understand Forget's impact on a pretty diverse set of real-world apps. And we're really confident about major design decisions, but might need to make further adjustments and optimizations depending on data. Our next step is to scale up until Forget is used everywhere at Meta, refining on small details. Finally, when we have stress tested and iterated enough, we release. While we still have some work ahead of us, we strongly believe that Forget will help React achieve its vision, an ergonomic developer experience paired with great performance. Thank you.